And we have people from all over the world following it. Just to be honest with you guys, this is a trial version, and that's why we invited the select group of people to be here today. But it's really the first time that we do together the meetup between Snowflake and Dataiku. So I'm always very pleased to do these kind of things with our partners. So thank you for joining tonight. I think most of you know me, but I'm Hielke Visser, working for Dataiku. And tonight I have a couple of special guests. On one hand side, Peter Janssens from Snowflake. And I have my colleague Greta coming from the UK, who has been working with Snowflake and the customers in the UK already. So that's why we asked her to join tonight. And very special welcome for Bart as well, Bart Cook, who joined Dataiku last month. And I'm very pleased to work with him and to build further the success. So we're going to do a little bit interactive, where Peter's going to tell a story about Snowflake. Greta will show you, tell you about Dataiku and how we integrate Dataiku with Snowflake. And in the end, Peter will come back to explain a little bit what has happened on the background. It's a small group, so we can have some questions. But because we are streaming, it would be good if you use the microphone if you have a question, or otherwise we can do it at the end, something like that. But that's better for the people who are not here in the room. I'm not sure if we should treat it like that, but that's what we agreed. Just small housekeeping. After the presentation, we have about 30 minutes to have a drink at the bar, and then we will close the bar as well. Sorry. And very special attention for GoDataFest, an event that we organized together with GoDataDriven, the host of tonight of the location. It's a whole week of a technology festival where we have on a Tuesday, we have a dedicated Dataiku day as well. So if you're interested in GoDataFest, I think we have some flyers outside there as well. And another small housekeeping, it's okay to drink here, but if you can bring your bottles and cans afterwards to the bins or the bar, that would be really appreciated. With that, I'm handing it over to Peter.
Thank you very much.
The floor is yours.
The floor is mine. I'm facing a bit of a challenge because typically I talk about this stuff for days if you let me. And I believe I now have something like 20 minutes. The good news is that most of the presentations will be done by Greta on how you want to deploy Dataiku in this case on top of Snowflake. So I'm doing the boring part. I'm very good at doing the boring parts of the evening. Everybody has its own talents. What can I say? So anyway, my name Peter Janssens. I've been with Snowflake since November. I've been doing pre-sales basically all my life. I was born a pre-sales guy apparently. Been working in information management all my life. I was just telling some of the attendees. I started my professional life as a COBOL programmer, writing extract programs to extract data from the VSAM and IMS databases to create data that went into Lotus 1, 2, 3. That's how you end up in business intelligence and analytics, and that's how I ended up implementing Snowflake in the cloud. So, who is this Snowflake guy? Let me give you a quick overview of the company. In 2010, two very, very smart engineers from Oracle started looking at this thing called cloud. And for the people who have some experience interacting with Oracle, Oracle was at the moment not so cloud savvy. Let's put it like that. Long story short, 2012 they said, you know what, we're going to leave the company. We're going to build our own product. So what these gentlemen did was they built a SQL database, a data warehouse engine, purely for the cloud. Let me tell you what they did not do. They did not take something that was already there and put it in a cloud environment. They started programming, building, architecting a new data warehouse system from scratch, purely for the cloud. Did I mention cloud? There's no, let me do a download of Snowflake. There is no download of Snowflake. Snowflake runs, I think I mentioned it before, in the cloud. At the time, it just ran on AWS. Since January, we have been developing for Azure. And only just now, I saw the announcement just now, we're officially live on Azure, yay. And the next step from our CEO is what he calls global Snowflake, worldwide Snowflake, so to say. That basically means that it doesn't really matter on which cloud supplier you're using, because you'd be able to use Snowflake in any place transparently. That's future selling, and I promised myself not to do that. So let's go back to what's happening today. So 2012, 3 people started engineering a data warehouse engine for the cloud. I think I mentioned cloud before. Fast forward to 2014, or actually early 2015, they went live as a company, and they said, well, we're pretty good engineers. We have a solid product on AWS, but we're not the people to build a company. So they attracted some people who could build companies. Bob Muglia is now our CEO. Bob Muglia was at Microsoft, where he had a fallout with Steve Ballmer and said, you know what, I'm going to do it myself. Bob is, like I said, Bob is now our CEO. He's been leading the Azure development within Microsoft, so he knows a little bit about cloud, I would say. He's been one of the pioneering engineers of SQL Server, which many of you may recall. So he knows a little bit about databases. That's always good news. He also knows how to build a company. Fast forward to today. Today we have over 1,500 customers actually using the product. And there's an enormous range of customers actually using the product. Because it's very easy, you go to snowflake.com, you swipe your credit card, and you're a customer. So you're one of those 1,600. At the other end of the range is our companies like Nike or Capital One, who basically said, well, you know what, we have all these huge Teradata machines and the Netezza machines and what have you, which is costing us a lot of money. Let's get rid of those and migrate all that stuff to the cloud. I'm going to be using the word cloud a couple of times more in this presentation. So that's where we are today. Earlier I was just mentioning when I joined in November, my personnel number was around 300. We're now almost at 600. We plan to be at 1,200 at the end of this year. Interesting proposition. We're growing like crazy, really. So don't know what that 1,600 number is going to be by the end of this year, but it's growing fast. That's really the company. Why is the company called Snowflakes? People ask me. Well, it's a data warehouse database, so it must have to do with data modeling. No, it doesn't. So for the people who can see this, this is the backdrop here is actually our reception area at Snowflake headquarters. Over here you see a little ski lift. Those 3 developers that I was talking about just now, those engineers, they're crazy about skiing. So the company's name is Snowflake. There's some logic there. This has other ramifications as well, you know. In general, American companies, they have their yearly sales kickoff meetings in Nevada, in Las Vegas, you know, in the desert. Or if you're lucky in Orlando, Florida, in Disneyland, basically. So we have them on top of a snowy mountain. Yay! Anyway, that's the reason for the company's name. People like to ski. So, what was the philosophy of these guys building that product? The philosophy was, we want it to be a complete SQL database. Why does it need to be a complete SQL database? Because everybody has been using SQL databases for ages. You know, when I say big data, I'm betting that just about every one of you now thinks Hadoop at some point. For example, Hadoop, that's all of a sudden you need a whole new set of tools that you need to learn. You need to bring in an enormous amount of engineers to make that Hadoop happening and to support that Hadoop system and what have you. They did not want to go that route. They said, well, you know what? The SQL knowledge is already there. The SQL tooling is already there. Guess what Dataiku does to communicate with Snowflake? It generates SQL. I will be showing that later on. Yay! We wanted, I mean, before, well, I was less great than I am now. We were talking about open systems. The system had to be open. And typically at that point in time, we meant Unix. Okay. We are saying, well, we want the system to be open. We want everybody to be able to use it. Well, that's good news. So it's SQL, so I can just do selects from where, order by, group by, and all that wonderful stuff. But now my reflex was, okay, so it's just a replacement for, you know, all these guys, Oracle, Teradata, what have you. It's a bit more. And the bit more comes from all of your data. Because typically, when you're creating that Hadoop environment for your big data, you're putting everything there. You know, extracts, the CSV extracts from your point of sale system, but also the videos, and also the JSON coming in from Twitter, and also the JSON coming in from your weblogs and what have you. It's all there. And it would be nice to find correlations between all those data items. So we said, well, you know what? Yeah, it's going to be a complete SQL database. You can do all your structured data in there, like you're used to in a SQL database. But we also allow you to what we call variant data being loaded into the system. So a JSON document, for example, comes in, and we load the JSON document. And by the way, we also understand what's in there. So if it's a tweet, we see the hashtags. We see the user ID, the Twitter user ID. We see the date and time the tweet was tweeted. The tweet was done. I don't know. You do a tweet or you tweet a tweet?
Send it.
Send the tweet. Thank you. The date and time the tweet was sent, and so on and so forth. So all the different components are there. So when I start querying that, I can just say, well, you know what? Give me a count of all the tweets done by Peter, or by what have you. Or look at the increase in tweets about my product and correlate to my point of sale information, because my point of sale information is going to be there as well. So many of what today are use cases for big data, where very often the Hadoops of this world are implemented, you can cover with that relational database as well. Did you notice I skipped one? There's one in between here. And it's zero management. I'm a techie, so I hate the word zero. Let's call it minimal management. When you're building a data warehouse, it's not enough to just say, hey, I'm going to use Snowflake, so now I got a data warehouse. You'll still want to think about dimensional models, or maybe data vaults, or a combination, or maybe third normal form, or what have you. That kind of management will still occur. Because, you know what, buying a data warehouse just doesn't happen. Buying an engine to make data warehouses happen, that happens. But sizing, scoping, putting infrastructure in place and all that wonderful stuff, that's done. Getting started with Snowflake means I give you a URL, a user ID and a password, and you're on your way. You start loading data, you start querying your data. We don't do predefined scoping. A very good example here is a customer of ours, Deliveroo in England. They do meal deliveries. So over the weekend, those scooters are all over the place in many of the big cities. So Monday morning, everybody wants to know what happened. So what they call Monday morning mayhem, all the analysts come in, around 100, and at 9 a.m. they all want to ask their questions. So to support that, you would need to scope and size that system to enormous, basically. We don't. Scope and size, well, you are in the cloud. The data is in the cloud, so just connect to the cloud and you're on your way. You don't have to predefine how much I'm going to use it. You just use it. And guess what? On Monday around lunchtime, everybody goes, have lunch. Don't use the system, and the system says, okay, I'm going to suspend myself. Don't predefine what you need to build, because you're going to be building a system that's going to be idle for 95% of the time. You know what? Let's AWS take care of the idle time, or Azure, your choice. That's the zero management part. Like I said, all of your users, that kind of connects to that complete SQL database. It's from well, a customer of our Mart parcel. They do daily reporting. They run a couple of reports and they know what to do. But all the way down to the data scientists at Deliveroo who say, well, you know what, I'm going to go find some kind of trends and some kind of outlier in my data. Not quite sure what I'm looking for yet, but I'm going to find it. All of your users using the same one source of the truth. That's the one thing that really attracted me when I joined Snowflake last November. It's the promise of data warehousing that has been around for decades is finally coming true. We're going to have one source of the data where everybody can get to. And then there's another cloud promise there, and it kind of relates to the story that I was just telling you about Deliveroo. You pay only for what you use. So on Monday morning, between 9 and 12, Deliveroo pays a serious amount of money for all that processing that they do. Why do they do that? Because it's of immense value. After lunch or over lunch, the system suspends itself. And guess what? The invoice goes back to zero for that time. You literally pay only for what you use. Did I mention cloud? There's just one system right now, a database management system in the cloud that can do that. Because those 3 engineers that I was talking about just now, they started to build a new cloud-native system from scratch. They didn't say, yeah, you know what, I'm going to take Parexel and just going to put it in the cloud and call it Redshift. Because, you know what, that guy is going to be running 24/7, even when nobody's using it. AWS is very happy with that, because you'll be consuming resources, even when nobody's using it. Just an example. And there's, of course, many of those. You bring your on-premise system, you put it in a cloud environment. Basically, what you have is a cloud system with all the on-premise limitations attached to it. So Snowflake is really, it's the cloud-native database. And then the last one, it wasn't architected from the beginning, but it makes it very easy to connect people to that database, to connect people to your data warehouse. Nielsen, for example, is a big user of Snowflake. Nielsen basically supplies data and information to retailers, to fast-moving consumer good companies, and what have you. And it used to be the fact that well, you could do a request for data, and then some analyst would get that data for you. He would put it, either send it to you or put it on an FTP site. You can download it, you can look at it, you can recognize, yeah, this is what I asked for, but not what I need, so you're going to change your request, and so on and so forth. Nielsen is now using what we call the data sharehouse to actually connect their customers to the data warehouse. Like I said, a URL, a user ID, and a password. Ask your questions. The data is live. If your response is not what you expected, change your question and go against the live data once again. How does that work? So, like I mentioned, these are really a couple of, oops, that's one too many. These are really a couple of the use cases. It's data warehousing, classical data warehousing. Many people are seeing that their classical on-prem data warehouse is growing beyond what they expected. And of course, the supplier says, yeah, we can scale up. Scaling back down is the interesting thing. So we do a lot of data warehouse replacements. You see data marts, data extracts, because, you know, building that data warehouse typically takes too long and doesn't bring what the users want. So they build it themselves. They create their own little data silos. And then one person at logistics says, yeah, the revenue number is X. And the guy at sales says, no, the revenue number is 2X, I guess. If you're a salesman, everything is always bigger. He's not here, so I can say these kind of things. Oh, Hilke is there, sorry. Hey, Hilke. Anyway, so to integrate that, and the third part where I mentioned the variant data, the semi-structured data, whatever that means. Typically living in a big data environment, in a data lake environment, can be integrated in there as well. So if I fast forward just a little bit, it's about consolidation, it's about modernizing data warehouses, and it's replacing data lakes into one system. And that's what we see today, people using Snowflake for. These are just a couple of these use case examples. So, now I can see it out here. This is the backdrop of the architecture. I think you need to have very good eyes to recognize that there's a snowflake kind of thingy. There you go, very good specs. Great stuff. Because this talks a little bit about the architecture. And I'm going to really do my best to talk a little bit about this. At one point in time, I needed an hour and a half for this one slide. You probably want to listen to Greta a bit more than to me, so I'll do my best, really, I promise. Classical data warehouse databases. It's an engine connected to its data. So if I want to grow the data, I'll need to grow the engine as well. It's not, they can be separated. If it's an MPP system, it gets better because you can scale up, but it gets worse because you need to do a lot of work to make it scale up. You know, you have this MPP system and the data is connected to the nodes in the cluster. So I'm going to add a cluster. I'm going to have to redistribute the data. I had one customer coming to me and he said, well, you know what? I'm a data engineer. I spent 5 days on basically engineering data. Guess what? Per week. But I'm spending the whole weekend to basically make sure that the system doesn't crumble the next week when people start using it. So he's going to look at, okay, so what are my analysts going to do this week? I need to size my system. I need to, this week I'm going to need 5 nodes in the MPP cluster. So I need to redistribute my data across those 5 nodes. And he was spending his whole weekend just to make sure that the system wouldn't crumble. And he was very successful. It only crumbled Thursday evening instead of instantly. Yay. Needless to say, now he's running Snowflake and he has his weekends free. Anyway, so what did we do? We said, well, you know what? The data needs to be in where the cloud provider supplies data storage. So when you're talking Amazon AWS, you're talking S3. S3 costs you $20 a terabyte a month. You know, for me, it's more expensive to say this than to actually get an S3 subscription. That's where the data lives. Now I want to go and process the data, so I will have an SQL engine, a virtual warehouse. I hate that name. Why do I hate that name? Well, the virtual part is nice because it's a compute engine, that's all it does. The warehouse sounds like it's containing data, and it doesn't. The data is here. How does that compute engine know which data to get when you say select revenue, group by region, and what have you? Well, the brains of Snowflake, the metadata. That's where the brains are. That knows which blob do I need to get from that S3 bucket to actually satisfy this request. And usually it's not one blob, usually it's a million blobs. And because the word blob sounds like a 60s horror movie, we call them micro-partitions. Sounds much more expensive, doesn't it? Basically, that's our business model, by the way. We sell compute cycles. Amazon sells storage. So that's I think when you go to snowflake.com, that's one of the first things you see. We separate storage from compute. Which is good, but that's just a technical thingy to make stuff happen. What kind of stuff? Well, you can have one SQL engine talk to many databases. You can have many SQL engines talking to the same set of databases. You can size those SQL engines. This is where it gets interesting. So Deliveroo has, on Monday morning, all their sales users come in. And at that point in time, they're potentially talking to what we call an extra large virtual warehouse And an extra large is 64 nodes. Within 3, maximum 5 seconds, 64 nodes MPP engine is started up for them. So when you think about it, when you run an MPP cluster on a machine or a set of machines, your limitation is that machine or that set of machines. When you run it in the cloud, your limitation is the cloud. Don't know if you can call that a limitation. Actually, I don't want to call that a limitation. You know, when you run on the AWS data center in Frankfurt, that's your limitation. That's the box you're running on. So when you're running a 5XL cluster, and yes, we have a couple of customers running 5XL clusters, they're running 512 nodes MPP engine. How much? Let me say that again. They're running a 512 nodes MPP cluster. Yay. Well, that must be ridiculously expensive. No. Why is that not the case? Well, imagine I have this query and it runs against a star schema, so it gets some fact data, it gets 5, 6, 7 dimension data tables, and it joins all that stuff. So that's many threads going on to satisfy your request. Well, of course. Because the database is, I don't know, half a petabyte in size, it takes 5 minutes to complete. Something like that, I don't know. So now my manager comes in and it says, I have a meeting in 1 minute, I need those numbers now. So I'm going to fire up a 4XL cluster. Takes about 3 seconds. And I have, I don't know, 128 nodes at my disposal. I'm going to run that same query and it's going to finish in 3 seconds. 4. Yeah, there's a Dutch saying, het komt uit de lengte of uit de breedte. It either takes a while or it's very fast. But the price is going to be just about the same. I want to say it's 100% linear, because I'm on camera and marketing is watching as well. I'm also a techie. I know that 100% linear doesn't exist, but we're pretty damn close. Does that make sense? So the price of that query is going to be the same. It's just going to be much faster. So you can scale up. So when you go from an extra small, XS, that's how they are priced and named, by the way. If you go to snowflake.com, you can find all that stuff. The pricing is there. So if you have a single node cluster, whatever that means, it's an XS, extra small. You can have a small, that's 2 of them. You can have a medium, that's 4 of them. You can have a large, that's 8 of them. And so on and so forth. 248, 16, 32, 64. 128. So you basically double the number of processors running for you, but you also double the memory size. You're doubling the cache on that thing. You're doubling everything. So you're also doubling your speed. Yay. You know, as we say in Amsterdam, it can be pretty damn fast if you want it to be. We calculate the price on a per second basis. So if you run only 3 seconds, you pay for only 3 seconds. But you would pay for 3 seconds on 128 nodes if you run a 4XL, 3XL. If you say, I don't care, you know, I just kick off this query and I'm going to have lunch or something, use an extra small. Interesting thing. So marketing says, separate compute from storage. Good news. I had a colleague of mine, he said, yeah, well, if you think about it, we also separate compute from compute. Say what? Because basically, if, for example, this guy has this query and it runs for 3 minutes, it will always run for 3 minutes. He can be on his own on the system. He can be running concurrently with 1,000 other users on the system. It'll only run for the same amount of time. Because what he's doing is 100% separate from what these guys are doing, and so on and so forth. That allows you to reach concurrency numbers that, you know, they just blew me away. We have one customer, we have this dashboard. It's a multi-tenant environment. It's cloud, multi-tenant environment. We manage it, data warehouse as a service. So we have this dashboard, and we can see, okay, so how is the system being used? We had one customer, a German customer, and over the last 30 days, they had one, what we call high watermark, maximum concurrency. That's not the number of users, but that's the number of requests being fired at any point in time, of 3,000 something. 3,000 concurrent requests being satisfied at the same moment. Okay. This gentleman that I was talking about just now, this data engineer, he was really worried if he expected more than 25, 30 users on the system. When I saw the 3,000 the first time, I didn't believe it. I was going like, no, 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 that must be wrong. That's marketing. No, that's what's actually happening. It's a different mindset. It's a different way of thinking about these type of things. Make sense? So like I said, there's so much more to it. It looks like a data warehouse, but you can do semi-structured data as well. JSON, XML, Avro documents. Just read the document in. It will be parsed when we read it in. And you have your schema available to you when you query it. Yay. What would you like to connect to it? Well, any of these. You know, the query tools, the reporting engines, the Sparks, the Dataikus. I put Dataiku logo in there as well, as promised. And so on and so forth. Typically in retail, you see a lot of MicroStrategy. How do you say that? The operational reporting type of thing. Finance users, Microsoft Excel. The most used, most widely used BI tool in the world. You know, MS Query, connect through ODBC. Just use any old SQL tool, connect to that system, and you're on your way. That basically means that Mr. Data Scientist using Dataiku to look for linear regression and do predictive analytics is looking at the exact same data as Mr. Finance in his Excel spreadsheet. You're kidding. No, I'm not. One source of the truth, and it's in the cloud. So Peter, your engine, where does it put its data? Who cares? It's data warehouse as a service. It's in an S3 bucket somewhere. Okay, that's fine. See if I care. You know, Amazon encrypts it. Snowflake encrypts it. You can add your own encryption key if you like. Interesting thing, because typically what happens when you talk about cloud, people go, "Ooh, security." I think 2 years ago, Forrester did some research on security of data centers. I think the number 1 was AWS, the number 2 was Azure, the number 3 was Google. Then there was a whole bunch of nothing, and then came CIA, FBI, and what have you. And then came the banks. Sorry. Big concrete walls, you know, I don't know. Make sense? So really, that's the boring part of the presentation. This is, look at that wonderful stuff that customers are doing. I really love this one. If you have a query that runs for 3 seconds, it will always run for 3 seconds. If you're by yourself on the system, if you're with a million other users on the system, consistency is key here. What do you need to do to make it happen? Nothing. I give you a URL, a username and a password, and an invoice, and you're on your way. And then there's, forgot to mention, one of those developers, one of those engineers that I was talking about earlier, actually he did his master's here in Amsterdam. While he was studying, he invented a query database called Vectorwise. The fastest query database, the fastest single node query database in the world. The man was studying, you know. He's part of the core team of engineers still within the company, and he's one of the guys responsible for queries that ran for half an hour now run for 20 seconds or something like that. It's a Snowflake in itself. If you want to know, it's a column store, and it's just ridiculously fast. oh, but is it faster than my whatever, my Vectorwise or my Vertica or whoever says that they're the fastest? You know what? My previous job, I was actually implementing Vertica. And I can make any query in Vertica run faster than it runs on Snowflake. What is he saying? But you're going to need me for a day to make that query run faster than anything else. And then the next query comes, and I'm going to make that faster. And I need to be very aware of the fact that I don't break the query that you had before. A colleague of mine made a very, very excellent comparison. If you want to go from Amsterdam to Paris really fast, get yourself a Red Bull Formula 1 racing car. That's going to be really fast. By the way, you're going to need, I don't know, 400 people to actually keep it going fast. You can also get yourself a Porsche 911. You know, it will just be sitting in front of your house. You get in, you turn the key, and you go really fast. That's the kind of distinction you need to make here. This thing, it's the 911. It goes really fast, and all you need is a URL, a user ID, and a password. Did I mention cloud? And it's pretty nice to play with as well, indeed. So yeah, that's the space we're in, really, if you think about it. So I'm not going to bother you anymore with all those boring data stuff. I'm going to say thank you, unless there are any questions around this. Then next up is Greta. She'll be showing you what kind of wonderful stuff you can do with this data. And afterwards, we'll give you a little peek in when she did all that wonderful stuff, things happened in that engine as well within Snowflake.
Yeah, in your previous slide, you're talking about the concurrency.
Yes.
Yeah, how it has been, how we can improve better, remove concurrency.
Yes, you don't have to improve the concurrency because it's part of the platform.
Yeah, means, did you take any different measures as part of this architecture?
The key, that's really the key that I was mentioning earlier is Snowflake was built from scratch for the cloud. So basically, when I say, okay, I'm gonna fire off a virtual warehouse, it is going to be there for me. And that's in Snowflake terminal or in AWS terminology. That's an EC2 engine. So over here, when I have 25 sales users, I give them a virtual warehouse, which is an MPP cluster, which is, I don't know, if it's a medium virtual warehouse, it's 4 EC2 engines. And by the way, they are 100% separate from this guy. So the concurrency, the limitation on concurrency is basically the AWS data center. It's pretty big. Does that make sense?
Yeah.
So that's how we came to have a customer that had a high level concurrency point of more than 3,000 concurrent queries running against the database.
Okay, so in cloud-based architecture, you have not, like with this particular architecture, you have not have a problem of connection, like connection getting lost in terms of having this architecture?
If you have a bad internet connection, the connection might get lost. That's a network issue. That's the internet. If there's a problem, if someone pulls the plug on my router, then it will. But that's probably not your question.
No. My question was, you are having another cluster, like you are having another for removing this concurrency. You are having another cluster or something similar to that.
Indeed.
Yeah. So, like, don't you think that it is basically having one more connection and it might result in performance?
From the user to the system, it's just one connection.
Oh, okay.
Imagine you're in Microsoft Excel. You're opening, what's it called, MS Query, and you have this SQL that you want to fire off. That's the one connection. If it runs against an extra small, it runs on that node that you're talking to at that point. If you're running at anything larger, an MPP virtual warehouse, multiple EC2 instances, the distribution of the workload across the cluster is done by Snowflake. You can even go as far as to say, well, by default, my cluster is extra small, so it's a single node, consumes hardly any resources. But now I want to go really fast, and if I have the authorization, of course, I'm going to say also warehouse set size 4XL. All of a sudden I have 512 nodes running for me. It's going to fire up 512 EC2 instances, pre-provisioned with Snowflake in it. Wow. Now I'm going to issue my query, select something from something, group by, order by, where, and so on and so forth, inner join there, outer join there. And it's going to distribute that workload across that MPP cluster. I don't know that. I don't care. I just issue a query. Does that answer your question?
Yeah. Thanks. Thank
Sure.
you.
One more question.
Hi, my name is Ayub.
Hi.
In one of your slides, I saw you replace the staging area and the data warehouse and data marts by Snowflake. So you have several reasons to make data marts. One of the reasons is to make it faster, or to have just a set of data available for, I don't know, for finance. But this really means that you do not need data marts anymore because you can speed up anytime.
The answer is yes. You typically, from an architectural and an implementation perspective, don't need to actually do that. What happens is that people, let me move fast forward one. Want to go here? Let's put the users in there as well. What happens is that people are using tools that like star schemas, for example. Gee, I would really like to use a star schema because then everything happens automatically. I think Tableau is magic with star schemas. I don't know enough about Tableau to validate that, but let's assume. What you can do is basically have your data in here in any model you want. I would say probably, definitely more than half, maybe 70 to 80% of my customers are building data vaults, because many data sources pushing data into the system and would like to be able to query it and recognize where the data comes from and so on. Tableau doesn't like data vaults, so basically they push data either into a virtual data mart by using views or maybe even materialized views, or they actually build a physical star schema. But this is where it gets interesting. It's going to be in the same database in that same bucket.
But then you have virtual data mart.
Indeed. Indeed. So from a technical perspective, it's not a requirement. It can make life easier for end user tool users. But you know what I mean.
And data cleansing, where do you do that?
I don't. That's a very silly, simple answer, isn't it? The key thing is really, what I'm supplying is a database engine. And that engineering team that I was talking about is pretty damn good in supplying that database engine. So when data cleansing needs to happen, for example, in ETL world, we work with partners like the Talents and the Informaticas and the Colibras and what have you of this world. That's where the data governance happens. That's where data cleansing happens. That's where the data stewards look at the data, make changes to the data and what have you.
That's something you typically do in a staging area.
Could be, yeah.
But you replace the staging. You only have one Snowflake.
Yep.
How do you do that then?
So when data comes in, it can physically directly get loaded into that data vault model, for example. You can also say, well, you know what? When I'm loading that data, I'm going to mark it as new, not yet validated, open to data stewards or what have you. So then it's physically already in the data vault model, but not not published or accessible for end users, for example. Or you can even, within that same bucket, build a staging environment where you would keep it until it can be pushed and propagated into the warehouse. That's really a choice you can make on a use case by use case basis. But it's going to be in that same environment, in that same bucket, on that same place. That's where the data lives.
Okay, so that slide you were showing is actually meaning that it's not like you don't need it anymore. You still can use it, a data mart or a staging area, but everything is in the same bucket.
The technical implementation is going to be very different. It's all going to be in that same bucket. Many organizations basically put the entire data lake in that same bucket.
Yeah, I got it. Thank you.
Sure.
Any more? All clear? All right.
I'm going to say thank you.
Yeah. Thank you very much.
I'm going to the thank you. Yeah, there we go. What I'll do, I will make sure that, I don't know who, do I send the slide deck to you?
You did?
Because
you can post them on the meetup page.
There you go.
That's probably the easiest.
Thank you.
Dus dat. Oeps. Alsjeblieft.
Check, check.
Brilliant.
Sound good? You got the clicker right.
I think I'm all set.
Only the watch for like 3 seconds. Should be good.
Great.
All right, good to go. And good luck.
Thank you. I think I'm all set. Hello, everyone. And thank you so much for coming today and spending the evening with us and learning about data. I think that if you're a little bit tired listening about data, then just to warn you that there is more conversations and talks about data today. So just to let you know. Right, so I'm Greta, and I'm from Dataiku. I am a technical alliances manager at Dataiku, and as part of my job, I collaborate with partners, and we try to expand our power in the ecosystem. And one of the first technology partners that I worked with since I joined Dataiku was Snowflake, of course. And Peter, thank you so much for giving us an overview of Snowflake. I think it's an impressive technology innovation, and we're really thrilled to work with Snowflake and do some integrations with them. Right, so first of all, at Dataiku, what we do is data science platform, and our technologies are around machine learning and AI, artificial intelligence. So most of you must know what machine learning is, but just to ask you to get an idea about your understanding of machine learning. Are you in the data science field or machine learning? How many of you are in machine learning? Great, quite a few here. So what is machine learning? For those that you don't know what machine learning is a field of computer science that uses statistical techniques to give computer systems the ability to learn. Well, that's the definition of that, but for those that you know data science and you have worked with machine learning technologies, that you might think that that's just a cliche, as my French colleagues would say. Right, so my background is also in data science and in data technologies. And when I first started my career in data science a few years back, I felt like that. Like her. That's not me, but this is how I felt. So I thought that it will be fascinating and it will be fun to work in data science. So data science is definitely a fascinating world to work, and it's considered one of the most innovative job profiles that you can have nowadays. However, as I started working on data science projects and getting more knowledge what is happening in the data science world, I realized that people's expectations are a little bit different from what I initially thought. So on one hand, people expect from you to be smart enough to know and understand maths and statistics. On the other hand, you need to be experienced enough in order to have the domain expertise, and also adventurous enough to have the hacking skills. And all that they expected from a data scientist. Well, that's not very realistic. That's more like a unicorn, or actually maybe a geeky unicorn, stylish geeky unicorn. The reality is closer to that. So there is, unfortunately now, we all know that there are no unicorns. But the reality is that data science is a very complex discipline, and number crunching is not an easy thing, right? But what we're doing at Dataiku is to address the main pain points of a data scientist. So a data scientist usually have to deal with data, of course, and all the tasks around data, all the obstacles around data, which is preparation of the data, cleansing the data. Sorry, I might be repeating the word data quite a lot today, but this is all about data. It's the heart of everything today. So apart from dealing with all the problems around data, they have to build their machine learning models, and they have to be very sophisticated, not only on a mathematical level, but also on a business level. So they need to collaborate and work very closely with the business teams in order to understand the business problem and then implement it in their models. But they also need to understand the data very well, have insights, and visualize the data. So that makes the life of a data scientist quite difficult. However, what we are trying to do at Dataiku is to solve all the core pains, the main pains and problems of the data scientists, and at the same time align the whole organization, the whole data, all the teams around data to collaborate and implement their data science projects. So what we try to do is to orchestrate the teams, whether they are data engineers, data scientists, business analysts, whether they are coders, clickers, or if they prefer to work on platforms or open source technologies. And also, one more important thing is that the platform has been built in open source technologies, and it allows the users to still use open source technologies within the platform. So what we do is Dataiku actually introduces a new way towards, let's say, the data science democratization. In the platform, you will find technologies around data management, whether that is data standardization, data pre-processing, data cleansing. But at the same platform, you can also extend your project to machine learning and build sophisticated models around, on machine learning. So you can get insights on your data, but also predict based on your data. So in a nutshell, the platform allows you to set the path for enterprise and artificial intelligence. And what I mean by that is that it does not only give you the right technologies and architecture in AI, but it also enables you to set the right methodologies, the right processes that will make a project, the data science project, more successful and will finally lead to deployment of the project. So when we talk about model deployment, it's probably one of the hot topics nowadays in the market. And I'm sure that many of you must be working on projects that have been in the development, in the design or development environment for a long time, but they never went into production because there were different issues like miscommunication with other teams, not the right data or missing connectivities. However, what we try to do at Dataiku is to have a complete solution for you in order to make that model deployment into production as easy and as smooth as possible. Right, so on top of that, apart from providing you the right technology, Dataiku also enables a collaboration between the different teams. So how does it do that? Imagine that you have in a big organization, you have a team of business analysts that will define the scope of the problem and they understand the business problem very well. But on the other hand, you have data scientists that they are very good with maths and they know how to build the most sophisticated machine learning models. You also have analytics teams that they know how to analyze or visualize the data. However, their skills are limited to data visualization. Also, you have data engineers that will connect data, extract the data, prepare it, and make it ready for the data scientists. These teams usually do not communicate very well, or there is a gap in the communication between the different teams. So what they actually need is a single point of collaboration, of work, that they can work together in one single point. Having a platform that allows them to work at the same time, on the same project, on the same platform, it massively helps the communication and the collaboration between them. And that, as a consequence, leads to more productive and more successful data projects, developing and prototyping the data projects, but also putting them into production. So breaking the silos between the different teams, it's one of the strongest the strongest advantages of working with Dataiku. Right. So in order to support that, we have a very strong and powerful, innovative infrastructure. So first of all, you can connect to any data sources. So we're technology agnostic. I know that this term has been used quite broadly recently, and a lot of companies use it, and a lot of technologies. But what we mean with technology agnostic is that you can, first of all, you can connect to any data sources that you have in your organization, either that is SQL, if it's cloud storage, cloud data, flat files, clusters, wherever your data is sitting, data you can connect to. Another very important thing here is the infrastructure. So we can be deployed either on cloud or on-premise. There is no limitation around that. So you have the flexibility to choose where you will deploy the platform and run it there. In addition to that, we don't limit you to use certain technologies, but we help to put everything together in one platform and leverage the infrastructure that you have in your organization. Finally, another point, well, I can talk about this slide for hours, but one of the most important things here is that it provides an architecture that separates the production environment and the development environment. So usually on the development environment, you want to have that prototyping of the data models. So you want to connect to the data, create all the logic around data cleansing and data preparation, build the models, test them, and finally, when you're happy with the model assessment and model building, what you would like to do as a data scientist or as an organization that focuses on AI deployment, you want to push that into production and have data science, let's say, a self-service data science. So how do we do that is to provide you with separate environments for the development, and then you have your automation environment where you automate your models, and the models will run either using some specific triggers or in certain timelines that you will specify. However, there is also the notion of the API node, and that is for real-time use cases. So for example, if you want to do customer scoring or live detection of fraud in your transactions and bank accounts, then you can run your models on live data. So this is how DSS supports, from a technology point of view, the end-to-end development of data science projects, and enables that collaboration not only between the teams, but also integrating all the technologies together. Right. So how a typical data science project would look like is something like that. Well, this is just a sample project anyway. But the idea here is that you can have a workflow-based UI that will allow you to build all your steps in your data project in a completely visual way. However, something that I mentioned at the beginning is that apart from the visual aspects of the platform, you can still use SQL, Python, or other open source technologies. And that helps a lot the data teams that have different backgrounds and different skill sets. So for example, if I am a data analyst and I'm not experienced enough and exposed enough to Python or SQL, I can easily understand what is happening in this project. And I can also do my tasks here in a completely visual way. However, if I am an experienced data scientist and I have worked with Python or R for a long time, and I don't want to use visual or clicking in order to build my models, I can still do that in Python and just embed it in the project and in the process. So here what you see is, first of all, the data sets, which are the blue squares. These are different data sets, and the yellow or the yellow icons, they are data transformations. The orange ones are coding recipes or coding transformations, so pieces of code that are embedded in the project. And finally, the green ones are the models, the machine learning models that you have included in the project. Now, this project here was built on Snowflake data. And the points that how we integrate actually with Snowflake is on the data, of course. So the data here sits in Snowflake. And here are the main benefits of using DSS on top of Snowflake. So actually something that might be worth mentioning is that we have a natural integration with Snowflake. So Snowflake will give you the data. The data will sit in Snowflake warehouse, data warehouse, in the cloud. And DSS will sit on the top and will interact with the data, but without needing to extract the data from Snowflake. So your data will still be on the cloud. Dataiku will connect to that data. You can preview the data, transform it, do your machine learning models, or apply any visualizations, and push it back to Snowflake. How does that help? First of all, you don't really need to write any code in order to interact with your data. You can, but you don't have to. You can interact with your data in a completely visual way and process it directly in Snowflake. So the data processing will happen directly in Snowflake. That means that the computation power that Snowflake gives us, and as Peter explained to us before, it can still be used by DSS, so you will leverage the computation power of Snowflake, but as a data scientist or as a data engineer, as a DSS user, data science user, then you don't really need to see that. So that is happening seamlessly, and you don't need to know what exactly is happening in the background. We have built, so what we have done with Snowflake is to build a strong connector that allows you to connect to the data in Snowflake, but also load data from S3 buckets and load them directly into Snowflake without having to go to S3 and do the manual work from somewhere outside of DSS. So you can do everything end-to-end from DSS. Again, the table creation will be automated by DSS, the data movement. If you want to run a SQL query, you can write a SQL query embedded in your project, and that will be executed in Snowflake. DSS, so Dataiku DSS is also integrated with notebooks, so you can use notebooks, Jupyter notebooks for interactive analysis with the data. And of course, you can do some visualization and some charting in order to get better insights of your data. So that is, these are actually the main benefits of having DSS and Snowflake at the same time. It's like you have the data in Snowflake. You interact with your data directly from DSS, and the users, they don't really need to know what is happening in the backend. You still have the computation power of Snowflake, but also at the same time make the most of the benefits that you get from Dataiku. So is there probably any questions that you have so far around our integration, around Dataiku platform? then I could quickly show you how you can build such a project in DSS. DSS, sorry, is the shortcut for Data Science Studio. It's the name of our platform. We call it Data Science Studio. It's shortcut DSS. So quickly jump into a quick demo here. So this is my project, but that's not a screenshot anymore. This is on the platform. One of the main benefits of using DSS is that you can use it. It's not a desktop deployment. It's accessible via a web browser. So that means that every person that is working on a project, they can interact and collaborate at the same time. Oh, my license is expiring soon. I have to renew it probably. Right, so everybody can collaborate at the same time. Of course, you can have a view of your project and different metrics around the project. You can see how many components I have, what kind of components I have in my project, and also what edits did I make on my project. And of course, I can revert the changes back. So we have an integration. The platform integrates with GitHub, so it works in the same way as GitHub, for those of you that are familiar. So you can revert any changes back at any point. Right. So the project that I decided to show you today is actually based on bike sharing data. I chose that project on purpose because I'm in Amsterdam. I mean, it's the city of bikes and cycling. So I thought that, okay, that makes sense. This project makes sense. What I have done here, what I tried to do here, was to use a data set from the bike rental data set from New York City. And based on that data, I wanted to predict how long it will take for a bike user, a person that is renting a car, to get from one place to another if I know the start and the end point. So I had my data, so that's my data that I found online. It's open data. And then I put it on S3, so that's an S3 bucket. So something very important here to mention is that the data that you preview here is just a preview of the data and not the actual data. Your data will always sit on the cloud or on whatever infrastructure is in the backend. So now,
You see that it's on Snowflake.
right. So,
Is it on Snowflake, this data?
so at this point here, it is on S3. Sorry, maybe I need to zoom in a little bit. So this is S3. But then what I'm doing here, and this is what we have built, and it's dedicated for Snowflake. It's a transformation, a Dataiku plugin, as we call it, that will allow you to load the data directly from S3 to Snowflake. So how I know, that's a very good question, that my data is in Snowflake. I can see here, sorry. So what I see here is just the data set, right? And I don't really need to know where my data is sitting. However, if I go to the settings, then I will see the connection that I've got. So the connection that this data set is using. So my connection is Snowflake here. The beauty of that is that I don't really need to know the connection details or how the data connects, how the platform connects to Snowflake. That is purely managed by the platform and the IT team.
You can do it the other way around as well. So put it in Snowflake and then
put it back in.
Dataiku.
And ingest it in Dataiku. Well, I could extract it in Dataiku, but that's not what I want to do. So if I follow, yes, not I want to do, but as a best practice. So as a best practice, I would want my data to stay on my database or data warehouse, just to be compliant and follow the best practices around security, data security.
Dataiku is not a storage place, so we don't store the data. We always connect to a storage.
Yeah, I understand. You can store it in a data warehouse as is Snowflake, and then ingest it in your Dataiku data science platform. I would do it that way.
I mean, there is flexibility to do whatever. Yes, there is such an option, but what I would ideally want to do is to keep it there. So I don't want to move the data in other places, because what I want to benefit, how I want to benefit from that, is to use the computation power and storage in Snowflake instead of pushing it, taking it in the DSS and then putting it back in Snowflake. Right, so another, as a next step, I have done a little bit of data preparation here. So these are, I did some, if you see on the left-hand side, I've done some data cleansing, data standardization, and feature engineering or data reduction in order to prepare my data for the machine learning part.
But this is not specific for Snowflake?
No.
This can be done for every database?
That's correct. That can be done for every database, every data structure, and it can be also flat file, like a CSV file as well. You can do it for any data source. But at this particular example, I'm doing it for Snowflake. Right, and finally, I have a data set that is more complete and in a situation suitable for, it's ready for machine learning and ready for my model. So I have extracted my features, and I know that I'm thinking that the start time or the month that I have in my data set will actually affect my model. So if I have, for example, summer months, I will see more usage in the bike rentals, but in December, because it's cold, people do not prefer to use cycling in order to commute. I will see the usage of the bikes going down. And
where's the data at this point?
The data at this point is still in Snowflake. Yes.
And then it's a copy, or it's just a view over the original data?
No, it's not on the original data, it's a copy. So what I have done here is to create, and what DSS does here is to create another instance, a copy of the data in Snowflake, but it will never affect the original one. We don't really want to change the original data source, and especially data that is coming from a data warehouse. But what we want to do is to create like staging areas, staging tables. Right. And I can see here also I'm doing a grouping of my data, because I want to have a better understanding and do some insights, get some insights on the data. So I'm doing a grouping, and again, I can do that in a completely visual way. And I can see here that my engine, if you see down here, my engine is a SQL database, which in my case is Snowflake. So that means that the computation power and the engine of Snowflake is being used for the processing of the data, and not DSS engine, so not Dataiku engine. Of course, you can choose to change that. However, it's important if you have that choice to push down the processing of the data. It helps you in the performance, the scalability, and it leverages all the benefits that Snowflake will give you. Finally, yes, before doing my models, I have done some some smaller data sets and created some charts. Again, these charts are for me as a data scientist to understand better what is going on in the data, maybe get some additional information. For example, here, I wanted to see which are the busiest bikes in New York. And these are the top 10 busiest bikes in New York, according to my data. But I can also do a lot more when it comes to insights and dashboarding. So I can see here another chart that I've created is to get some information around the stations, the busiest stations. So these are the top 5 stations with the most charts. Anyway, the idea here is that you can use the built-in functionalities of the platform to get better insights, either in a graphical or in a visual way.
In which step are the charts saved now?
Oh, okay, that's a good question. So you can build charts and do analysis of your data at any point, in any step, on any data sets. I think that I have done here a couple of charts, maybe. So it doesn't really matter at which data set you have done your charts. But
Tabs, and then you can go to the charts tab and then build your charts.
yes, you can always go to charts and just select the correct data set that you want to analyze and view there. Okay, so that's another one.
Here as well that it's SQL execution is done in Snowflake. So whatever your size is, we leverage that capacity. So we're not doing the execution on the Dataiku server.
Yes, thank you, Helga. And right, another one here on this particular data set was a rider performance by age and gender. And I can play around with the graphs here a little bit, but these are more for me as a user to understand my data. And finally, whatever charts I'm building and the ones that I want to share with my team, I can put them on a dashboard, and so that all the team can see that. And that's important when it comes to communication with other teams, like business people, because they want to understand a little bit what is happening nowadays, now in the data, or at every stage of my project, especially when you work on a complex project. So this is pretty simple, but sometimes you get like a lot more data sources. So you can combine different data sources, one from Snowflake, some other from an API, a URL, etc. And the project becomes a lot more complex. So you need to have that visibility and make your project more self-explanatory, let's say, to the whole team. And finally, yes, you can export everything in a dashboard and have it there. Right. So on this part here, sorry, I should actually be using this, but yeah. So on this part here, what I'm doing is building my machine learning models. And again, in the platform, you can find 10 built-in machine learning models from Random Forest, XGBoost, etc. So here I have trained quite a few models. And what is interesting about that? Oh, anyway, I can't. It seems that I cannot open that, but the idea is that I can see which model, I can see the performance of my models, and I can compare which one is the best one. So I'll just create a new one here. The way that I can build a model is pretty simple, and it's just a few clicks away. So I just choose a prediction model, and I want to predict the trip distance, and I will have an automated machine learning model on a quick prototype. So now it's building my models, and I can go to the design and choose my features first of all. So everything that traditionally data scientists would have to code, I can do it in a completely visual way. So I don't need to be an experienced data scientist in order to understand that. I can understand how the model works much better if I just use the visual aspects of the platform. So these are the different features that I have in my data set. I can simply enable and disable them and choose a few ones that I want my model to run. I can generate more features or remove some other ones. And finally, I can choose from a list which models I want to train. So I'll just choose 2 for now, and I'll train my model. So my 2 models are now being trained. So that means that the models are learning from the existing data how to perform and what features they will use in order to make the predictions on my test data.
So this is done parallel due to Snowflake?
So this is using also a Python engines in order to do the processing, because the models are built in the background in Python, but the input and the output of the models will be stored in Snowflake. Right.
But the Python is running on the DSS server or in Snowflake?
Sorry?
The Python is running in Snowflake?
No, the Python and this one is on the DSS server. Yes. You can choose to change that if that does not comply with your infrastructure, but Python is in DSS.
What I understand now is that Snowflake can do it in parallel, simultaneously. 2 models, train 2 models.
Snowflake can train, sorry?
Snowflake can train 2 models simultaneously, so parallel. I don't know if Dataiku can do the same, but I think Dataiku is doing first random forest and then bridge.
No, the idea here is that the models are being executed in DSS, in Dataiku, but the data is the input and the output is stored in Snowflake. So the whole model execution and the model build is happening in DSS. Yeah.
Can I comment on that?
Sure.
That's only if you can put it differently. Parts of the model, sorry, I was going to shout. So part of the, actually on is probably a good idea. There we go. The part of the training of the model which can be translated in SQL can then be handed to Snowflake, which can then definitely run that part of the code in massive parallel mode. Run it on a 2XL or something like that, and it will run in MPP environment. Very much dependent on which algorithm you choose and how much of that algorithm you can actually translate into SQL.
Yeah, but because you run the 2 models on the same data set, and Snowflake has splits it, so you can use 2 views of the data set.
Correct.
So then you can run the parallel.
Oh yeah, in that sense.
Models can be built with SQL. That's the challenge.
Oh, I understand that. I understand.
Yeah.
When it's
I
SQL,
understand
it's
that,
better.
but you can run Python in Snowflake as well. I've seen that.
So can Snowflake has the capability of running as a kind of a order in a thread pool, like running parallel? Does it have the capabilities?
As long as it can be translated into SQL. We're an SQL 99, ANSI SQL 99 engine for processing purposes. So that's a limitation. There's always a limitation. Sorry about that.
Sure. So at this point, I can see my models that are being trained, of course, because I just used random features, etc. The score of my models is pretty low. So what I can see here is the score, so the performance of my model. So if I have a lot of models trained at the same time, I can compare which one gives me the best performance, and I can choose that one to be deployed on my flow. I think that I won't wait here for random forest to be trained. I can just go back to my flow, because I have already done that with another model that I've built in the past. And finally, what I do at this step here is to use the deployed model. So I choose my best model, the one that has the best performance. I apply it to my test data, which is the data that I don't know the distance that it will take me to get from point A to point B. And my model will predict the target variable. So at the end, I will have a data set with a prediction. So that is my data set. And finally, I will have a prediction on over there. The prediction is the distance, the time that it will take to get from point A to B in seconds. Right. So that's a quick overview of a very simple data science project, but that is mainly to give you an idea, a flavor of how a typical machine learning project would run from the beginning to the end. Finally, when everybody, all the data teams and the experts that are working on the project are happy with the results, they have tested the models and they wanted to put it into production, DSS Dataiku will give you all the capabilities around productionization in order to push it into production, and then you can connect it to your Snowflake production warehouse. Right, so any questions so far?
Who are your competitors?
Sorry?
Competitors? Who are competitors of Dataiku?
Competitors? Well, that's a tricky question, actually, because some of our competitors can be on the data management and data analytics, data preparation side, but their limitation is that they focus only on one part, and some other competitors, they focus on the machine learning, so they do deep learning and a lot of built-in visual models, but again, they focus on this part here. What we provide is more like a complete solution for the enterprises, for the businesses to apply and have a central platform that all the projects can be implemented end-to-end, and all the data teams can collaborate. So yes, we have the technology around data pre-processing, the technology around machine learning, but our uniqueness is that we combine both and make it available and kind of democratize those technologies to everybody in a company and an organization.
Doing everything, and what I like most is that you can make charts at any point, and charts work very well to show something. So you can talk with the business and say, look, if we do this step, then the chart looks like this, and the next step, the chart looks like this. And that's what I like a lot. So it's a way of talking with the business. Makes it easy.
The way of working together is the thing.
Yes, the collaboration and model explainability, let's say, that's a real power, I think, that most companies don't have nowadays, and they really need to. So yes, collaboration is definitely one thing, and making those models understandable from all the team.
Together at one time at one project.
Well, I asked it last time, but I don't remember actually. But how does it work again? Because working together gives some complexity about who's working on what, and how does it work again? Like, can you lock certain parts or something when you're working on it?
Oh yeah, absolutely. So you can control the level of access on different people. So you might have someone like a project manager, profile like project manager, that you don't really want to make any changes on the project, but he or she needs to understand what is happening. So that person will have only view access rights. But on the other hand, you will have data analysts that can do the pre-processing of the data, and data scientists that can do that they can do actually everything, including the machine learning part, and administrators that will have full control of the platform.
Yeah, but if the two data scientists can do the same, in theory, but if one is working on step A, is it then locked, and so that the other one cannot work on step A, or?
It will be visible. So if there are two users on the same data block, for example, the same processing step, you will get a red box saying user B is also working on this step, be cautious.
Yeah, exactly.
Cool. So how much time it takes to build this project?
Well, it took me like 2-3 hours, to be honest. But in a real project, because this is a demo project that it's quite simple, and the use case it's pretty straightforward. In a real use case, it might take you a little bit longer, like from a few hours to a few days. It really depends on the complexity of the project. However, what we have heard from our users and customers is that they reduced, one of them that I was talking the other day, he said that we managed to reduce the time of the development and deployment of data science projects from 18 months to 2 months. From 18 months that it was traditionally taking, like on average, to 2 months. So that was a huge amount of time that they were saving, just the time. And on top of that, the complexity and the fact that you can have everything built in the platform, it adds, it makes it, let's say, it makes the life of all the data experts much easier. So it enables not only to deliver projects faster, but also better quality of projects, because they can have the insights from everyone.
Any more questions or done? Nothing? Norms?
Are there special functions available only for Snowflake?
Special, sorry?
Are there special functions only available for Snowflake, which are not available for other data sets?
So yes, what we have here is a plugin. So the plugin is actually a component of the platform that extends the capabilities of the platform and allows the integration with other technologies if they're not built in the platform. So we did that plugin here just for Snowflake, in order to allow the connectivity to the cloud storage and creating the tables directly from DSS and loading the data as well. Apart from that, the native connector. So the native connector that we currently have is for Snowflakes. I will show you that. So if you would like to add a new data set on the workflow, then, sorry, you will choose your connection and choose the Snowflake connector in order to use the data set from Snowflake. So a native connector and plugin are what we currently have, and we're investing a lot on the Snowflake integration partnership as well. We're doing a lot of work and collaboration together, and we're planning to build in the next couple of months by the end of the year to enhance actually our connectivity integration with them. Oh yeah, if you have any ideas, or whoever is working on Snowflake and Dataiku and has some ideas around that, I think that this is the best time to let us know what needs to be built, what would you like to see, because we're currently under the development phase of enhancing the native connector. So, is there any other question or something else that you would like to see?
Could you quickly show what's been going on in Snowflake when you were running that project?
Oh, yeah. Sorry. I was actually planning to do that. Thanks, Peter, for reminding me. Right, so in Snowflake now, what is happening? So as you see, I didn't have to go to Snowflake at all, but I want to see, just out of curiosity, if everything that I was showing you is actually somewhere in Snowflake. So if I go to the Snowflake UI, I can see all my databases, warehouses, etc. And finally, if I go to history, that's the quickest way to see what is happening. I can see here that Dataiku has run all these queries in the backend, and the time that it took, and all the details anyway. So I can see all the queries, all the processes that Dataiku run automatically in Snowflake from here.
Maybe a question, but I think that's free. What is selecting if it's running on an extra small or a large cluster in Snowflake?
I believe in this specific situation, we said, well, we just, for a relatively small project, we just default to an extra small.
Okay.
But you can actually, that's one of the things that I think maybe your product manager would be interested in, to be able to say, okay, now I want to run this part of the project on a medium or an extra large, because that's going to process a large data set, for an example, but only for this specific part, and then scale back down again because you don't want to spill your resources. I believe the default here is an X small. Or in fact, you can see at the selects, you see which size it was running on, and it's an extra small. So it's a single node.
Yeah. So this is actually, I believe that this is when I do a preview of the data and display a sample of the data, it's just running a select query on the top 10,000.
So how do we troubleshoot here? This is the way to check, okay, this is the time taken for each query for troubleshooting?
For the time spent in the database, yes, that's where you find in the history.
Okay. Indeed. But apart from that, if I need to have any other troubleshooting, how do I?
You won't have troubles. You won't have troubles anymore. Forget about troubles.
Your
life is different. We can tell.
For example, you can query add the query plan.
Yeah.
If there's a big join, you know, there's a 5-way join, you can ask for the query plan. Where am I spending most of the time within the query? It's of course there's much more detail there for each specific query. But that's I mean, this is a relatively small project, so the queries being generated are relatively easy.
Right. So that's actually the beauty of using the platform on top of Snowflake, because we're like complementary to complementary technologies. What you want to have is that power of Snowflake, the computation, the scalability, and the power that Snowflake provides you, but also that level of visibility and running everything on top of Snowflake completely seamlessly. So as a data scientist, data engineer, business analyst, I don't want to see what is happening in Snowflake. I just want my query, my flow to run fast. And something that Peter mentioned before is that concurrency. So if my model takes 30 seconds to run, let's say 30 seconds, it will always take 30 seconds. Even in the production environment, it will take the same. So I know exactly what is going on, what will happen also, not only in my design and prototyping phase, but also in the production phase. Yeah.
Okay, thank you very much, Greta, for your detailed explanation, and thank you as well for Peter. And thank you all for joining. And yeah, let's take the opportunity to have a drink at a bar till for half an hour or something like that, so we can all be fresh tomorrow
thank you, everyone.
again. And don't forget about GoDataFest, 6 days festival of data technology coming up soon. Thank you, and thank you, Thomas, as well for hosting and live streaming. We got some nice comments on the internal HipChat room about Peter's presentation, so it was cool. Thank you.